Now today we shall discuss about the escape energy. Okay, if we throw a stone upward with our hand, it goes to certain height and then falls back towards the earth. If it throw with a larger speed, so we throw with a larger speed, then what will happen? It gets greater heights. Okay, that is our experience. If a stone thrown with such initial speed, it goes to infinite distance from the earth's gravitational field forever. In this position, there is no attraction on it by the earth. Try to understand this sentence. If a stone is thrown in such a way that it has a tremendous initial speed and it goes to infinity, okay, and at that point the gravitational field of the earth or a gravitational attractive force is not experienced by it. It goes to infinite distance and we can say it has gone out of the earth's gravitational field forever. Okay, the thoughts of this situation is like this. Suppose a body is lying in the gravitational field of the earth at a distance r from the center of the earth. So we have, say, one object which is away by a distance r from the center of the earth. So the object is lying somewhere here and this is the earth. Okay, this body is stationary for, and the total energy of this body is in the form of gravitational potential energy, and that gravitational potential energy is negative because it is the binding energy. So it is minus G MEM upon R. Okay, so at distance R, the gravitational potential energy of the object whose mass is m is given by negative of minus GMEM upon R. This will be the gravitational potential energy. There is no motion, so it does not have any kinetic energy. So total energy is in the form of gravitational potential energy, and as you know, total energy is the sum of kinetic energy and potential energy, and here there is no kinetic energy, it is stationary. So kinetic energy is 0 and potential energy is in the form of gravitational potential energy, and that will be minus GMEM upon R, where R is the distance of that object from the center of the earth. So this can be written as minus GMEM upon R. Okay. Now try to understand. If you have the object at certain height h, then the distance from the center of the earth will be h plus the radius of the earth, and it can be written as total energy is equal to minus GMEM upon RE plus h, where h is the height of the object from the surface of the earth. Okay. Now, at infinite distance, what will happen? At infinite distance, this total energy of the body is considered as 0, because when you are at infinite distance, this denominator becomes infinity, very large, and this value of energy is 0. So if the energy is, say, positive G MEM upon RE plus H. Negative energy is a binding energy, that is the potential energy of the object. If this much amount of energy, that is positive GMEM upon RE plus H, or the energy more than this value is supplied to the body, then what will happen? If external energy is this much and its binding energy is minus GMEM upon R, or rather RE plus H, if you take the height H, then the energy of the object at height h is minus gmem upon re plus h. So the object is at height h. Say for example, this is height h, and radius of the earth is re. So total distance from the center of the earth is re plus h. Okay, so at re plus h distance, the potential energy is negative, that is binding energy, and that is minus gmem upon re plus h. Now if you apply external energy as positive gmem upon re plus h, then what will happen? That is the energy which is given in the form of, say, kinetic energy. Then the total energy becomes zero. Positive energy which you are supplying plus the potential energy which is negative, so the energy becomes zero. Okay, and the body will go to the infinite distance. It does not return in the gravitational field of the earth, and this energy which is supplied from outside, that is positive energy which you are applying from outside, that energy is called the energy which is escape energy. So escape energy makes the object escaping out of the gravitational field of the earth, and it goes, rather object goes to infinite distance. Okay, now we shall talk about the escape speed. Now try to understand, when the object is at distance r, that is small r, from the surface of the earth, then what will happen? The situation will be like this that I have explained. Say for example, you have this earth, and this is the center, and the object is somewhere here, that is at distance r. This much part, that is radius of the earth, and this much part is the height of the object. So we can say that distance r, that is from the center of the earth, is re plus h. Try to understand. So the distance of the object here is the height of that object from the surface plus the radius of the earth, that is total distance from the center of the earth will be re plus h. Now potential energy at this point, that is gravitational potential energy, will be minus gmem upon distance r, and instead of r, if you write re plus h, then the equation of this gravitational potential energy will be minus gmem upon re plus h. So this is very clear to you. Now if that object is stationary at distance r from the center of the earth, then its kinetic energy becomes zero. Okay, kinetic energy becomes zero, and the potential energy is minus gmem upon r. So total energy is the sum of kinetic energy plus the potential energy, and it will become this way. We can write, okay, kinetic energy plus potential energy. Kinetic energy is zero, okay, and potential energy is minus gmem upon r, and instead of r we write re plus h. Okay, so we have total energy as minus gmem upon re plus h. Now if you are supplying the energy from outside, this much amount of energy is supplied from outside, that is a positive amount of energy that you are giving to the object from outside, that is positive gmem upon re plus h amount of energy you are giving. Positive gmem upon re plus h amount of energy you are giving from outside, and this energy is in the form of kinetic energy. Okay, so if you are supplying this much amount of energy from outside, the total energy becomes zero. Okay, and the object will go to infinite distance from the earth, and this is nothing but the escape energy. and to speed, rather, the object which is obtaining, the speed which the object is obtaining is called the escape speed, and the energy which you are supplying from outside is in the form of positive GME m upon Re plus H, and that is in the form of kinetic energy. So the speed associated to the object when you are supplying this positive GME m upon Re plus H amount of energy to the object, that is called the escape speed. Speed associated with the object when you are supplying the energy, that is positive GME m upon Re plus H to the object, that speed associated with the object is a escape speed, and that energy is a escape energy, and that energy is in the form of kinetic energy. And as you know, kinetic energy is 1/2 mv square. V is the escape speed, and that amount of energy which you are supplying is gmem upon Re plus H, that is positive value. So the minimum amount of energy with which the body should be projected from the surface of the earth so that it escape from the earth's gravitational field is nothing but the escape speed. Sometimes it is taken as escape velocity. Now it's very easy for you. Okay, you have this equation number 2. Okay, just we have to make VE square as a subject of formula, so this 2 will be in the multiple here, so it becomes 2GME. This small m will be cancelled out, okay, and Re plus H will be there in the denominator as it is, okay. So VE square will be equal to 2GME upon Re plus H, okay. So VE will be square root of it, okay. Now if the body is on the surface of the earth, then this height will be equal to 0. So taking h is equal to 0 when the object is on the surface of the earth, the escape speed will become under root of 2GME upon Re. Okay, just you multiply this equation by Re and divide also by Re. Then here it becomes GME upon Re square, okay, into Re, and GME upon Re square is nothing but gravitational acceleration small g, whose value is 9.8 meter per second square on the surface of the earth. So the equation will become under root of, okay, under root of 2GRE, okay. And if you place this value g as 9.8 and Re, that is radius of the earth, as 6400 kilometer, you have to convert it into meter. 6400 into 10 raised to 3, okay. And if you simplify, okay, then this speed you are getting, okay, that is escape speed about 11.2 kilometer per second, okay. You can write in equation 4, okay, we can take the mass of the earth as 4 by 3 pi Re cube into rho, where rho is the density of the earth, and you can simplify the equation and escape speed can be obtained in different way, okay. But this is the standard equation of escape speed, okay. That is very important that you keep in mind, and value of G and Re if you substitute, then this VE, that is escape speed, is obtained approximately about 11.2 kilometer per second, okay. You can also see from this equation that the escape speed does not depend on the mass of the object which is to be taken away from the surface of the earth. Any object, whether light or very heavy, the escape speed required is constant, that is 11.2 kilometer per second. The another thing here, it also does not depend on the mass of the earth. It just depends on the radius of the earth. Okay. So mass of the earth and the object which is to be taken away from the earth's gravitational field or from the vicinity of the earth. Okay. It does not depend on both the masses that is to be taken or the mass of the earth. That is a notable thing here in this equation. Okay. Now we talk about what is satellite. Okay. The body revolving around the planet in the direction of revolution of planet is called the satellite. Okay, motion of satellite is very similar to the motion of the planets around the sun, hence Kepler's law of planetary motion are applicable to them. Okay, there are two types of satellite, natural satellite and artificial satellite. As you know, moon is the natural satellite of the earth whose time period is approximately 27.3 days. Okay, artificial satellite, okay, that is man-made satellite which are put in the different orbits around earth. Okay, the first artificial satellite was a Sputnik. Okay, by the Russian scientist it was put in the orbit. Okay, then successful launch of Aryabhatta and ncert series of different satellites by our Space Research Organization ISRO. Okay, satellites are used for scientific, engineering, communication, weather forecast, spying, and military geographics or military purpose they are used. It is used for meteorological survey also. Okay. Now we talk about orbital velocity of satellite and we derive its equation. Say for example, the orbit of the satellite is shown in this figure. Okay, the mass of the satellite is m and the height of the satellite is h. So total distance from the center of the earth will be re plus h. Okay, and its orbital speed is vo. Okay, vo, and it is orbiting around the earth. Okay, so the satellite is experiencing the attractive force is gmem upon r square, where r is nothing but the distance that I have explained, re plus h. Okay, now as you know that centripetal force will be mvo 0 square, rather mv0 square we should write mv square upon r. Okay, so this can be written as mv0 square upon r. Okay, because centripetal force is nothing but mv square upon r, so it can be written as mv0 square upon r. And this centripetal force is provided mv0 square upon r it is. Okay, this centripetal force is provided by gravitational attractive force, so both the forces must be equal, so equating them, so mv0 square, now it is correctly written here, mv0 square upon r is equal to gmem upon r square. Okay, it should be r square because both the forces are same. So we are equating this first equation which is g mem upon r square, that is equal to mvo, orbital speed is vosh, mv square upon r. Okay, so one r will be cancelled out, so you will have vo square, this m will also be cancelled out, so vo square will be gme upon r, and instead of r if you write re plus h, okay, then this orbital speed will be gme upon re plus h and square root of it, because this is the square. So if you want to find vo, then we have to take the square root, so it becomes gme upon re plus h and its square root. Okay, this equation indicates that as height h increases, h increases. Try to understand, denominator increases, then orbital speed decreases. Okay. Now, gravitational acceleration on the Earth's surface, as you know, it is gme upon re square. Okay, that we have derived the equation. Okay, so gme can be written as g into re square. So instead of this gme here in this fourth equation, this gme is replaced by g re square. So the equation will become under root of g re square upon re plus h. And if you take re as, because it's square it is, so re can be taken out of the square root, it becomes under root g upon re plus h. Okay, and if a satellite is very close to the surface of the earth, very close means if you take height is equal to 0, then orbital speed can be equal to, you can write easily, this height is 0, so this equation will become re under root of g upon re. Okay, and the equation can be, this can be taken inside again. If you take this inside, then it becomes re square. Okay, so just you can simplify this, okay, by writing it as re square. So we can write vo is equal to under root of g re square upon re, and as you know g re square is nothing but gme. So instead of this g re square, try to understand from this how this has come. Okay, if you take height is equal to 0, then it becomes re under root g upon re. Okay, so now if you take this re inside the square root, then it becomes re square, so it becomes g re square, which I have written here. So under root of g re square upon re, and this g re square is nothing but capital gme. So instead of this capital gme, okay, instead of this g re square, we can write gme. Okay, so g into me upon, it is written as re. Okay, so vo is equal to capital gme upon re and its square root. Okay, so it can also be written as this way, under root gre, which I have explained. Okay, if you want to simplify this, say for example this equation you try to understand, vo is equal to re under root g upon re. Why? Because height is 0, satellite is very close to the surface of the earth. Now this will be cancelled out and here the square root will be. So this can be written as vo is equal to g into re, and both are having the square root, so you can write under root of g into re. Okay, it's just a matter of simplification. Okay, try to watch these 2-3 times, okay, and write them in the notebook properly, these derivations. Okay, thank you very much.